Okay, everybody, here's our last review day. So let's go through this. This is the last bit of information that we talked about near the end of the semester. So number one, graph these two lines and find the point of intersection. Okay, so first of all, let me go ahead and just start with my XY axis, right? So I can graph these, and I put this graph paper on my paper. That made it easier for me. So problem with number one is it's not really in the right form. I really want this first equation to be in what we call intercept form. Remember? So I'm going to go ahead and solve for y. I'm going to go minus x. I'll have a negative y equals a negative x minus 2. You can't add those because they're different. Now, this negative y is the same thing as negative 1. So I'm going to divide by negative 1, everything. And then, that's also 1. So then I'd have y equals, let's see, y equals a 1 over 1 x plus 2, because negative divided by negative. Now I can graph that. So I can start at positive 2. Let's see, I'll put these in different colors. That might be helpful if I put them in different colors, okay? I'll put this one in red. Start at 2, and I'm going to go up 1 over 1, up 1 over 1, up 1 over 1, because that's the slope. Okay, so then I draw in my line. Here's my first equation. Now my second equation I'll do in blue, and that's just this one here. Start at positive 4 for the y-intercept and go down 1 over 2, down 1 over 2. And then they don't exactly intersect in a perfect point. So the best we can do is estimate. And the bummer is, it's an estimation, and that's why we like to use the other methods. So sure looks like it's the point, so our answer looks like it's the point at 1.5 or 1.5, comma 1, 2, 3.5, okay, or 3.5, okay. Not the best answers. That's why we do it a different way. So number 2, we look at question number 2, and it is done a different way, okay. So I'm going to do substitution because I know what x is. So I'm going to do substitution. So I'll have an x equals a 2y plus 3, and I'm going to have a 3x plus 2y equals 25. So when I do substitution, I'm going to take then my, let me grab a different color. Colors are awesome. I'll take my 2y plus 3 and I'll put it in for x because that's what x equals. So I'll rewrite this equation as a 3 times, well, a 2y plus 3 because that's the value of x plus 2y equals 25. I'll distribute 6y plus 9 plus 2y equals 25. I'll combine my y's. I'll have an 8y plus 9 equals 25. I'll subtract 9, what is that? 14, 16? Should be 16, right? 25, subtract 9, should be 16. So I'll have an 8y equals 16. I'll divide by 8, and y is 2. So that's only part of the answer. The answer is obviously something 2, and if I need the something, well, then what I have to do is plug that in. So let's hold on for just a second. Here's my answer. Circle my answers in orange. So what I'm going to do is take this 2, I'm going to bring it and plug it in for y, because that's the value of y. So I'll rewrite this, solve for x. X is equal to 2, but not y, but what y is equal to. So I'll plug in the y value, which is a 2, and I'll go plus 3. Well, that's easy. 2 times 2 is 4 plus 3, x equals 7. So my point of intersection is 7, 2. Much easier than graphing it by far. Okay, there it is. That's my solution. Number 3, I'm going to do the elimination method because they're all lined up. So I'm going to do elimination. So let's eliminate the x's. So you eliminate the x's. Multiply this entire equation by negative 2 all the way through. Okay, so equation 1, let's rewrite. Equation 1, equation 2. Equation 1 is still a 2x minus a 3y equals negative 16, but equation 2 becomes a negative 2x minus 4y equals negative 12. Okay, now when I add the two equations, then the x's are eliminated. That's what we call elimination method, gone. So then we add, and we get a negative 7y equals, let's see, what's that, a negative 28? Yeah. And then I divide by negative 7, I get y equals positive 4. Now, y is 4, so my answer is, oh, screwed it up, sorry you guys, my bad, there's all my work, sorry, screwed it up. So my y value is 4, but I don't know my x value, so I'm going to take my 4, and I'll plug my y value 4, and I'll probably plug it into, I like that one looks easier. Take the original equation, 2x plus 2y equals 6. I'll put 4 right in there for y, so I'll go x plus 2, but I'm not going to write the y value, but what y is equal to, which is 4 equals 6. Okay, then I'm just going to simplify x plus 8 times 4, 6, then I'll go minus 8, and x is equal to negative 2 because 6 minus 8. So there's my solution. It's got to be negative 2, 4, always x, y, because the x-axis and the y-axis. There it is, ta-da. Okay, now, let's look at the back side. Okay, on the back side, I'm going to do some more graphing. And so I put graph paper here to help me out. I'm going to shade. I know I'm going to be, shading. Okay, and when I shade, what I'm looking for is where my shading overlaps. So I'm going to get some colors because I like colors to do this. So let's check it out. Okay, so first of all, first equation is not ready to be graphed. Okay, I've got to look at the 2x minus 3y is greater than 12. So I need to solve for y. All right, minus 2x, because I need it in slope-intercept form. Minus 3y, my bad. Minus 3y greater than a negative 2x plus 12 divided by negative 3. We'll have y. Oh, wait a minute. I just divided by a negative, so I turn the sign and make it less than positive 2/3 x minus 4. Okay, I didn't graph that. Let me get my graph set up. Let me do that. Graph set up. And let's put this one in red. How's that? So we'll do this one in red. Start at negative 4. 1, 2, 3, 4. I'll go up 2 over 3, up 2 over 3. It's going to be a dashed line because there's no equal sign, so it's going to be a dashed line. And I'm shading, right? So if I read this correctly, it is y is less than, which is shading everything below the line. So I'm going to take, and since I'm doing this in red, I'll just take my pink marker and shade everything below the line. Okay, all right, good. All right, now let's take a look at the other one. So we'll do this one in blue, and it's already ready to go. You just have to be careful because that's a 1. So it's really y is greater than or equal to, if I rewrite it, y is greater than or equal to a negative 1 over 1x plus 2. I just rewrote it, switched around, same. Makes it easier to graph. So I'll start at 2. I'll go down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1, down 1 over, okay? So forth and so on. And then I'm going to go ahead and do a solid because it has a little equal sign, so it equals the line itself. And, okay, there it is. Now, if I read this correctly, it's greater than or equal to 2. So in blue, I shade everything above the line, everything. Okay. Now, what I'm looking for is a solution to both, okay? And what I see is a region here, right here. So let's go ahead and count this as region 1, 2, 3, region 4. So region 2 is where both solutions occur, where the pink is shaded and the blue is shaded. So that is the solution. So I'm going to make that a little bit darker than all the rest. Put that in green. So I know that green is my solution. I'll make that much darker than all the rest because the others are solutions to one or the other or none. Okay, so then is point 2, negative 1 a point? Okay, so let's see. 2, negative 1 is sitting right there. No, it's got to be there, so the answer is no. It is not in this green solution. Okay, all right. So forth, so good, so far so good. All right, 5, a story problem. Okay, so the cost of tickets for the district championship game are $5 for students and $10 for adults. After the game, the accountant counted $33 in sales with 450 total tickets. So I've got two equations. One is, let's call it the money. the money equation. Okay, well, let's see. It would be easy for me to call students X, and we'll let the adults be Y. All right, $5 for students, $10 for adults, and I made a total of $3,000, okay? Then the second equation is tickets. Total tickets. Well, I'd have so many students plus so many adults has to equal a total of 450 students. Okay, so now, what I want to do is solve the system. So let me rewrite it down here. Okay, so that's the answer to the first part. Got the equations. But what I don't have is the solution. How many of each? Well, I can guess and check, or I can solve. Well, let me rewrite it. Equation 1, which is a 5x plus a 10y equals 3,000. Equation 2, which is an x plus a y equals 450. I'm going to do the elimination method. So I'm going to eliminate my x's by multiplying by -5. Okay, that's going to get rid of my x's. So if I do that, equation 1 stays the same. 5x plus 10y equals 3,000. But equation 2 changes to a -5x, -5y equals, hold on, this calculator's made 4. Hold on. All right, 450, whoops, 400, whoop, again, 450, I'm dyslexic, times -5. Oh, come on. 450 times -5, -2,250. And then when I add, the whole point is then the x's are eliminated, right? I get a 5y equals, well, let's check it out, 3,000 minus 2250 gives me a 750. Divide by 5, and I get an answer of 150, okay? Okay, that tells me I sold 150 adult. I know that. So then to get the student tickets, I'm just going to plug that in. Let's plug it in right there. Boy, that seems like the easiest place to plug it into. So instead of x, I'm going to take this equation right here, x plus y equals 450. I'll put my 150 right there. And so I'll put x plus 150 equals 450. I'll minus 150, x equals 300. So I'm going to say we sold 300 student tickets and we sold 150 adult tickets. Okay, that's all I have. Tomorrow's the final. Best of luck to everybody. Take your time. Do well. You can do this. I have faith in you. You can do this.